Okay, we're live now. So, quick introduction. Dan is going to explain to me how I have no idea how Crossplane works and Upbound and all those things. He's going to be very mean to me today and treat me like a newbie who just finished university, right? That's the sinister plan he has.
That's the usual vibe I give off, I think. So,
so welcome to the stream. This is my not the first day, but one of the first days in Upbound, and the whole idea is to make things very public. The idea is for them to allow me to not allow me to teach me how to deep dive into Upbound, right, into Crossplane and all the other goodies. So all to you, then.
Yeah, absolutely. Well, first of all, welcome to the Upbound team, Victor. I know that a lot of folks, both internally and externally, really love a lot of the content that you've already made about Crossplane. So I think you're going to be a little less of a noob than I think you may be saying. But I'm super excited to have you. For folks that have followed along on the Crossplane streams and things like that, and some of the Upbound streams. I've been doing a stand-in job of being our developer advocate, and Victor is much more skilled in that regard. So I am super excited to have him here. And today we're just gonna, as Victor said, we're gonna walk through stuff. I know that folks already know that being open and transparent, like Victor said, is a really big part of our company ethos. So I think it's super cool that we get to do an onboarding together. And yeah, I'm ready to jump right in if you are.
Oh, yeah. You just need to share your screen again.
Awesome. Sounds good. I'll pull that up. All right.
Cool. Shoot.
All right. So, Victor, I thought it would be a fun way to start off if I said, in one sentence, what would you tell me Crossplane means to you, or what Crossplane's about?
Extending Kubernetes API beyond Kubernetes itself.
Awesome. I like that. And that was a safe option, right? Because it's pretty broad. But I think that I like that you went broad with that, because I think that the capabilities of the system are really broad. And the first way that folks typically come to Crossplane is because they see that you can provision infrastructure on cloud providers with the Kubernetes API. And that's an attractive thing, right? Folks have kind of evolved in their usage of the cloud from using the console to maybe using an API to then using infrastructure as code in front of an API. And this control plane model is kind of the next evolution. So when folks see simple things like creating a bucket on AWS using a Kubernetes resource, that's definitely really attractive to them. And Crossplane can certainly do that. But we like to look at it as a platform for building platforms, right? So we don't only want to say that you can now create external infrastructure and consume it in your cluster using the Kubernetes API. We want to say is you can create new APIs based on those granular managed resources, and you can create a platform. And we typically go with kind of these two different personas, right? Infrastructure admins and developers. And as an infrastructure admin, you can create a platform that has the policies, the requirements, the abstractions in place that you want. And the developers can consume that infrastructure in a self-service manner that, makes it really easy for them to be able to get what they need without being worried about, getting specific approval or making sure that they're falling within the guidelines. You're kind of enforcing that themselves. And the nice thing is you have the same API for deploying your application and your infrastructure. So that's kind of the I guess paragraph summary that I would give of it. But I'm gonna jump in here. I know this is like pretty simple for folks that have already walked through this before, but I think just looking at the documentation is pretty useful.
Sorry for interrupting you for a second. Just to clarify when I understood, basically, it's partly, at least, right, about shifting left, enabling developers to do things, which traditionally companies take the approach of doing that by creating opinionated something, right? This is an easy way how you deploy application that we as a software vendor define, right? But this is slightly different. This is more about enabling some people in your company to actually create the opinions for the other people in the company. Would that be a fair explanation of what's going on.
I think so. And if you look at even AWS or GCP, they have provided services, right, which have their opinions. They may be very broad. For instance, you can do almost anything you want with an EC2 instance, but they're giving you kind of like granular resources, and then you have to build platforms in front of that kind of are doing what you're saying, right? Where you're saying, this is how you deploy an application in my organization. And we're allowing you to do that a lot easier, right? So you don't have to build your own bespoke system. You get to, in minutes, which we'll see later on, you get to kind of define that own platform that your developers can use. So we're not actually going to install things here, but there's a few concepts that I want to touch on here in the docs. And we really jump into the most abstract portion here in the Crossplane docs to get folks started, which, some folks like that and some folks don't. But it does kind of get you 0 to a view of the end goal pretty quickly. So the first thing you're going to do after installing Crossplane is install a configuration package. And this is basically going to bring a bunch of these manifests into your cluster that define your abstractions over those granular resources. And the way it does that is a configuration package declares dependencies on providers, which are other type of package in Crossplane, which would be things like provider AWS, provider GCP, kind of similar to a model like Terraform, where you have plugins and you can add, targeting for any API. And the configuration says, I need that logic to be present in the cluster to be able to provision those types, but I'm going to put my layer in front of them and tell how they're composed together, and we'll look at how you do that in a minute. But this is how you can kind of build your platform, right? When you're installing configuration packages into your cluster, you're saying, this is what I want my platform to look like for developers. So in our documentation here, we're installing a pretty simple configuration, which we'll actually see a kind of variation of in a minute, that just brings a simple Postgres instance abstraction here. And as you can see, this is pretty simple. It's not specific to a cloud provider. So you can see no matter what cloud provider you're provisioning on, it looks the exact same. And really all we're asking folks to do is define the size of the Postgres instance. And there may be some limits on that as well. Behind the scenes, we as infrastructure admins, or in this case, someone else who built this configuration package that we're installing, has defined both the schema for the abstraction. So they're saying that there's one field, it's storage, it's an integer, and it's required. And they've also defined a set of mappings where it says, when an instance of this abstract Postgres type gets created, I want to either create an RDS instance on AWS, create a bunch of stuff on AWS, including an RDS instance and all the networking around it, create a Cloud SQL instance on GCP, or create a Postgres SQL Server instance on Azure and a resource group. So basically, you can you can match anything to an abstraction, and you can even, this is showing one per cloud provider here. You can do some more advanced things, which we'll look at kind of towards the end of the stream, where you say, I want to provision a cluster and then use provider Helm to install something into that cluster all at the same time. So you can get really creative with how this works. You can also nest these within each other. So you can create an abstraction and put that in a composition for a higher level abstraction. You can take mappings from the abstract type. So let's go over the AWS one here. And, pretty much all these Postgres instances are allowing us to define the size of the database. That's something you'd typically be able to do for a database, but they don't all have the same parameters for doing that. So for instance, on the RDS instance, we're taking that storage GB field off of the abstract type, and we're mapping that to the spec allocated storage type for an RDS instance. And, that's opposed to on a Cloud SQL instance, for instance, where we're saying data disk size GB. So last thing here that you can kind of do with this composition, giving a high level view, is you can define from those underlying resources, which all may have connection information, you can aggregate information from the connection secrets of all of the individual resources in a composition up to a kind of higher level one. So depending on what you're provisioning, you may want, the username for a database and the password for the database, and then some like a kube config for a cluster, and that could all be in one composition. You could aggregate all that information up to the consuming application that provisioned with an abstract type. So I'll stop here. Victor, please grill me on some of the things I just said, or if you have any questions, let's get into them.
So those connection details, they are, how do I get them? Is that a Kubernetes secret, or there are other places where they can be?
Yeah, so right now in Upstream Crossplane, everything is a Kubernetes secret. You can do some creative things like kind of like mocking the secret interface in the API server, which can be a little complex. There's actually an issue open, which I believe is on the roadmap for 1.4, which will be our next minor Crossplane release, to support kind of arbitrary secret stores. So these could be written to Vault or KMS or whatever secret store you want. But the way this works in terms of taking these secrets for the managed resources and aggregating them up to the abstract type is each managed resource publishes a connection secret. So you'll see, for instance, in our composition here, write connection secrets to namespace. And here we're saying crossplane system. That means for all of the resources in this composition, I want them to publish their individual secrets to that namespace. And then when I aggregate them up, I pick and choose values from each of those managed resource secrets, and I'll aggregate those up to the connection secret for the kind of abstract type here. And that means that the developer that provisioned it can say, write my connection secret to this reference in my namespace, and it will be the fields that they need from the underlying infrastructure to be able to consume it.
And theoretically, I guess I could, over time, that could be published as well, right? Because right now the API, the provisioners, right, are, let's say, low level. Mm-hmm. But over time, I guess people could start publishing their composites, right? And making them available to others as well.
Yeah, that's exactly right. And we will show a sneak preview of what that could look like towards the end with our demo, hopefully. So
cool. Hurry up then.
All right. Well, I'm sorry. Geez, see, I told you you'd already know. Maybe you should be teaching me. I don't know. But that was kind of a high level overview, right? And so lots of folks use Crossplane, lots of folks use it in production. And we as Upbound want to be able to make that experience a lot more seamless. It looks like Jared just joined.
Hey, Jared.
Hello from San Diego, but he's not currently there. All right. So next thing we're going to do is go over to Upbound Cloud. So this is our Upbound Cloud console. When you create an Upbound Cloud account, which you can do by just going to upbound.io, if I can spell it right. And if you have a get started, you can go in and register. Then you'll get to your console. And so this is where I am. I'm in my personal console, my Dan Mangum account here. You also see you can have different organizations. So in your personal console, this is kind of where folks would go and do prototyping, experimenting, or if you have a side project or something, you might go in here and use that in your personal control plane namespace here. You can also go into an organization if you've been invited one or create one yourself, and you have those control planes and repositories as well, which we'll talk about in a moment. But you also have a lot of user management kind of features. So you can think of this as where you kind of your control center for all of the infrastructure in your organization. And we're going to see how you can see all of the relationships between infrastructure and where they're provisioned. What you can also do is invite users. So yesterday I invited Viktor to my Dan org here, and you can put them on teams. So for instance, I have this dev1 team here with Grant. I don't have any control planes or repositories right now. Actually, I might have a repository. Yeah, so I have a repository here that I've given Grant access to. And you can create teams and manage them. And this is actually all handled via Kubernetes RBAC under the hood. So we can show what that looks like in a moment. But that's kind of the distinction between personal accounts and organizational accounts.
I have a very important question. Are you using Mac?
No, I am on Ubuntu.
Okay, then I was about to say press Command plus, but I don't know what is the
No, I think that
shortcut
still
in
works.
Ubuntu.
Yeah, here we go. Is that better?
Do it one more time.
All right.
There you
Better?
go.
All right.
Yeah.
Well, we'll test out how our interface does here, enlarged. All right. So you can do team management. It's kind of the point there. Repositories are where you can push packages as well as just individual container images, which we'll show in a moment. Importantly, a really important part of Crossplane packages is that they are just OCI images. And we'll talk about what this looks like in a moment. The other parts of Upbound Cloud that are important is our registry. So I'll open up the registry here. Oh, that did not work. There we go. If I open up the registry, basically this is a public marketplace for where you can consume provider and configuration packages. So when you push your actual, individual packages yourself, you can make those available to the general public. And when we kind of design our platform here in a few minutes, we're actually going to use one of the configurations, but you can see that mine are here as well. For instance, that Adventures with Grant and Dan one that I published last week, as well as this My GCP one, which we're going to use later on. There's also a lot of kind of getting started packages here. And if you click on them, you can see exactly what they do, what they depend on, and that sort of thing. If it's a provider, you can see all the CRDs that it introduces, which, there's typically quite a lot of those. This one doesn't have any documentation, but you can add in annotations to basically tell more about, all of these different resources and that sort of thing. All right. So let me get back over to the console here. And now we're going to get to the most important part of Upbound Cloud, and that is control planes. Control planes you can think of as hosted UXP instances. Now, we haven't talked about UXP, but you can just think of UXP kind of like a Crossplane with some Upbound bits in there. It's really our enterprise distribution of Crossplane. So a few weeks ago, along with the CNCF, we announced that we have a conformance program for Crossplane as well as Crossplane providers. So Crossplane providers being, our provider AWS, provider GCP, et cetera. And then the Crossplane conformance program itself being for distributions, of which UXP is the first. So UXP, which stands for Universal Crossplane, is our Crossplane distribution. It's totally Crossplane conformant. You can actually be running Crossplane and with one command upgrade to UXP without any interruption of service there. And Upbound Cloud allows you to do one of two things with UXP. You can create a hosted control plane, which essentially means that we as Upbound will run a Kubernetes cluster with UXP installed and give you access to the appropriate parts of that to provision infrastructure using the Kubernetes API. You can also do self-hosted, which means that I'm going to run UXP in my own data center, or I'm going to run it on GCP today. I also showed, I think, in our last stream with Grant that I was running it on my local machine and he was provisioning infrastructure via my Kind cluster on my laptop. So you can run self-hosted anywhere. And also running self-hosted, right, gives you full control over your cluster. So today we're going to run self-hosted and also put Argo CD in our cluster and show what that looks like.
Yay.
But I'll start off with just creating a hosted one here just to show what it's like. So I'll call this one, let's call it Welcome Viktor. And I'll go ahead and create this. And so behind the scenes, what Upbound Cloud is doing here is it's creating a cluster, it's installing UXP, and when that comes available, I'll basically have kube control access to that cluster and can start managing it and installing packages from the marketplace, the registry, as I'd like to. I can also go in and say, with my teams now, let's create a new one. We'll call this the Welcome Team. And I will add a team member to the welcome team here. It's going to be Viktor. And I can make Viktor a member or an owner. I'll make you a member for now.
I'm going to see how much trust you have in me. Member, huh? Okay.
This is
I'll remember
day.
that. I will remember that.
You got to work up to it, you know. So I'll add Viktor to this team. So you'll see Viktor is here. I can say that I want to create control plane permissions and repository permissions. I'll say Viktor on our, well, it's still coming up here, so it'll take it a moment. But once our control plane comes available, I can give Viktor permissions to either just look at that control plane and see what infrastructure exists in it, or actually provision things there as well.
So this is, I think, kind of important, because one of the comments that I've been receiving long before I joined the company, right, is that chicken and egg problem type of question. Hey, okay, I want to use Crossplane to manage my infra, and that infra includes Kubernetes clusters, and I need Kubernetes cluster in order to run a tool that will manage the Kubernetes cluster. So, you know, and basically this can be a solution, potential solution to that problem. Hey, you actually have environment without creating your own Kubernetes cluster, at least not initially, right?
Yep, that's exactly right. And you know, we've seen folks who use the hosted, they want to do self-hosted, but they just spin up a hosted cluster because it's really easy. You know, one click here on Upbound Cloud, provision that self-hosted cluster, and then kill the hosted one. You know, you can do that. We also have had folks experiment with just, you know, running a kind cluster and installing UXP, and then going ahead and spinning up your self-hosted cluster and then killing the kind cluster. And
can you manage? Can you use Crossplane to manage a cluster where Crossplane is running?
Yes, you can. And you can actually, we have, so one of the examples, well, I'll go ahead and do it here. If we go over to the registry, let's look at something like platform ref AWS. And I believe this has a link to the, let's go ahead and do this. So this is going to take me to a guide here. So this is a package that some folks at Upbound have put together and done a really excellent job on. But one of the abstractions in this package is a cluster. And behind the scenes, there's actually two abstractions beneath that, one being for an EKS cluster, which sets up, I believe, like a VPC, the control plane for EKS, node groups, IAM roles, etc. If you want to, you can go in here and actually, you know, take a look at all the different things that get created. And then it combines that abstraction with this services one, which under the hood, this services abstraction is installing Prometheus into a cluster. So you can get really creative with Provider Helm and using it alongside other cluster provisioners. So you can imagine here, as Viktor was alluding to very astutely, that this Helm chart itself could be Crossplane, right? So you could be using Crossplane or UXP to install Crossplane or UXP into another cluster. And if folks are kind of interested in the different models for this, over in the Crossplane docs, we have a multi-tenant Crossplane guide here, which talks about a couple different models for, you know, managing multiple tenants, as the name suggests, from Crossplane or from UXP. And this is one of the things that's mentioned there, is kind of a cluster of clusters situation.
Nice. Now press Command plus.
More here? Or just,
no, in the previous one. Yeah, exactly.
these are the kind of things I was just, you know, to give folks a little behind the scenes in our company Slack. I was just saying, this is why we have a real developer advocate now who realizes when text is too small and folks aren't going to be able to see it. So we are very lucky to have you around. So our cluster is ready. So I will go ahead and show giving Viktor access to that cluster. So I'll create a control plane permission here, and I'll give you the editor access, which means you can do things in this cluster. All right. So now if Viktor came and actually logged into Upbound Cloud on his side and went into the Dan org, he would have access to look around in this cluster and do whatever he wanted to. So the other side of this is the self-hosted control plane, which I know we've already talked about a little bit. And with self-hosted, you have kind of the ultimate flexibility while still getting, you know, all of the features of Upbound Cloud. And that's what we're going to hone in on today for our demo. So it looks like we're getting close to kind of like halfway through the stream here. and we are going to finish it right at the hour or a little before. So let's go ahead and jump into the demo. Does that sound good to you, Victor?
Sounds great.
Awesome. Well, once again, going behind the scenes a little bit, Victor and I were chatting before we came on the air today, and we're both. I found out today we're both of the ilk of kind of tempting fate with our demos. So I'm guessing that over the next few months and years potentially, you are going to see a lot of pretty crazy demos between the two of us. So hopefully the one today will be relatively enjoyable as well. So I'm going to start off by looking at our cluster. So let's forget Crossplane, Upbound Cloud, UXP, everything for a moment. I am a small organization, or maybe a large organization, but given by the apps that I have, we'll say I'm pretty small. And I use Argo CD to practice GitOps with all of my deployments. That's how I put anything into a cluster. That's kind of how I manage all the applications within my organization. So you'll see here in my Argo CD console that I'm following the app of apps model. So folks that use Argo CD are usually pretty familiar with this model. Essentially, you have a single kind of like bootstrap app or management of apps app, and it is in charge of putting new deployments into the cluster. So let's look at the source for this, and let me make sure I have this up to date here, and I will make this larger. See, I'm catching on, Victor.
Yeah, good.
And so there's actually a lot more here than is actually deployed. But here is my app of apps. And right now it's just a Helm chart, and most everything is commented out here, except for in app team 1. I'm saying I want an Argo application that points to a Helm chart in my app team 1 charts hello world directory here. And in that hello world directory, I have a very simple Helm chart that's just a single deployment for the Nginx Hello World application here. And if we look over in Argo CD, we'll see that it's running. And if I go ahead and try to find that, let's make sure that it's actually there and functioning as we see. I'm going to make this a little smaller so folks can see. Let's do... If I get the command right, which I frequently do not, we're going to port forward this pod here, and I need to specify the namespace. And I'll do from 8080 to, I believe it's port 80 on the pod there. And let's make sure that that's up and running. All right. So we are good. This is a GKE cluster with a single Nginx Hello World deployment running in it. So as you can tell, we're getting pretty crazy with this demo so far. So I'm going to close that down. And now what we want to do is say, as an organization, we have some applications that are a little more complex than this Hello World one. I know it's hard to believe, but sometimes we want to have some state associated with some of our applications. And we went down the path of trying to run a database or multiple data services in Kubernetes itself. And that didn't go so well because we don't really have a lot of expertise around running databases. So we really wanted to use a cloud provider, which is really good at providing infrastructure services. But that meant that we had to go over and use Terraform or use some other infrastructure as code tool or go in the console and mess around. It definitely wasn't self-service. It wasn't managed through the same GitOps pipeline. So I like to say that once you break out of a GitOps pipeline, you're no longer practicing GitOps because something is outside of that. And we really just wanted a consistent workflow to be able to do that. So let's say that my organization came along and it heard about Crossplane, it heard about UXP, and wanted to get started in a cluster where we already have Argo CD running and we're already doing a lot of stuff. Well, a self-hosted cluster is a great way to get started there, and you can connect that up to Upbound Cloud and get that Upbound Cloud experience while still going through your same workflow. So I have the Up CLI installed here. And Up is how you interact with Upbound Cloud, as well as install and manage UXP and various packages that you may build for UXP. So I am going to simply, and this is going to use our kube config here. I'm just going to run a up-uxp install command, which is going to install Universal Crossplane into our Kubernetes cluster. And this should complete relatively quickly here, although you never know when you have the latency with GCP. And let's make sure that everything is running okay. All right, it looks good. We have this crash loop back off, but I'm guessing that's about to recover. What you'll notice here when you install UXP is actually the same components that you see with Crossplane. So we have the Crossplane pod, core Crossplane, which encompasses our package manager as well as our composition engine. And we also have our RBAC manager, which means that Crossplane has the ability to compose those managed resources for the different providers you may install, which we were looking at earlier. So let me make sure all those are healthy, and that looks good. After UXP is installed, and potentially before, if you're doing something like Viktor was talking about earlier with Bootstrap and cluster, we want to get to managing everything in the cluster with GitOps as soon as possible. So this is kind of similar to the app of apps model that we're talking about with Argo CD, where, for instance, to set up this app of apps scenario, I went in and I ran this single Argo CD app create apps and pointed at that apps directory. And then from that point forward, I was able to manage everything via my Git repo. So with UXP installed, the next thing I need to do is introduce some of those abstractions. So I have this really, really cool application that App Team 1 has been working on and wants to run in the cluster. It's called the stream counter. Basically, all it needs is a Postgres database, and it will expose an endpoint for folks to be able to basically say that they are joining the stream, excuse me. And go ahead.
This shows the evolution of you as a developer. You started with Hello World, now you're going to complicated stuff.
Well, yeah, I don't know how complicated this is. Please don't take this code. This is actually, I pulled this off a demo from a year ago, and there is all kinds of atrocities happening in this. You'll also see once we run this that I am not the utmost expert in front end technologies. That you'll see, I'm a big raw HTML fan, so we're going to get a lot of that here. But anyway, I want to run this application. We've been working on it. It's an important feature for our company, but I need a database to run alongside it. And like I said, I want to do that through the same abstractions or the same API that I'm deploying this application itself with. And so what I need to do is build a package that presents a database type to developers. So like that one we saw in the Crossplane documentation, and configure that with how I want that to map to underlying resources. So I have created my own composition package here, and we didn't take a look at this yet, but in a composition or configuration package, you can declare things like the version of Crossplane that you need, as well as the dependencies on providers. So today we're only going to be using provider GCP. So I'm just saying I need provider GCP, and it needs to be at least v0.13 or higher. Crossplane is going to see that and install the latest version that meets those constraints. And then I'm defining that Postgres type that we saw earlier and saying that I just need that to map to a Cloud SQL instance. Before we actually build and publish this, I want to point out that a really awesome use case for this is, there are folks that want to have in a development environment run their database in the cluster, for instance. And, when they move to staging or prod or something like that, they want the database to be, a Cloud SQL instance or something. Here, we've defined only a single kind of satisfying composition for our Postgres type, but you could define multiple of these. And the developer, which I'll jump ahead a bit here, the developer can request their database in their Helm chart, and it can look the same, whether it's going to GCP or running in cluster. All they care about is that they need a Postgres instance, and they want their connection secret written to their namespace. So this is giving them a really flexible abstraction here. And once again, this is kind of a simple example, but you can really get a lot more complex with your compositions. So the first thing I'm going to do is package up my composition and definition here, and I'm going to push that to Upbound Cloud to a repository. So once again, this is an OCI image. And in my organization, I can create repositories to push OCI images to. So this is similar to Docker Hub or whatever registry that you're most familiar with. And it is going to add some additional things on it if you're pushing a package, like making sure it's a valid Crossplane package and that sort of thing. You'll see that we've already created a My GCP repository here. I pushed once to it already earlier this morning, but I did make some changes. And so I'm going to push a new version of this. So let me go into packages and My GCP. And we can actually build our Crossplane packages using the up CLI. And that is basically going to produce an OCI image, and then you can push with up CLI as well. So the command to do that is up x package build. And if I don't specify a name, it's just going to use the one that is present in the crossplane.yaml and append the digest to it. And then I need to specify where I want to push that. Once again, if I don't specify the package I'm pushing and there's only one in the directory, it'll use that one. So I want this to go to registry.upbound.io, which will actually push to by default if I don't specify. And I'm going to make this Dan, my GCP, and we'll make this one v0.0.2. And so when I push that up to the registry is going to receive it. It's going to parse the contents of it and then let me know if it was valid. And if it was valid, it's going to say it was accepted. To give you a little bit of the behind the scenes of creating these repositories, when you create a new one, you can specify whether it's just a container image or whether it is kind of a special image, which is a package. You can specify whether it's public or private. Obviously, public meaning it's published in the registry and other folks can consume it. And private meaning that, you have to have access in my organization, which you can manage once again with your teams there. All right. So with this pushed up, I think you're on mute there, Victor.
Sorry. Those registries are Upbound registries, or I could potentially use others.
You could use others as well. Yep. So these are conformant OCI images. I could just as easily push this to Docker Hub. The benefit you get here, right, is that additional parsing. And then we can also see in a moment, if you weren't using GitOps, you can actually go through, and this is actually a great example. Since we're not going to use our hosted cluster, I'll jump over to the registry. And this Adventures with Grant and Dan one, we'll use this. I have this run in Upbound Cloud option. So if you push to the Upbound registry, you can actually install it directly into your control planes. You just select your version. We'll put it in that hosted welcome Viktor control plane, and it'll install that in there. And then when I go to my control plane, you'll see that I have my packages installed. So there's a number of benefits of using the Upbound registry, but you're totally right. You can use any registry you'd like.
Nice.
All right. So we have our local UXP instance or our self-hosted UXP instance, but right now we don't see any information about that in Upbound Cloud. So we need to connect this up to Upbound Cloud. So the command for that is upcloud control plane, or CTP for short, attach. That's how we attach a self-hosted cluster to Upbound Cloud. And I'll call this one Friday stream. And I'm going to create this in the Dan org. And then I'm going to pass the output of that, which is going to be a token for connecting a control plane to Upbound Cloud. I'm going to pass that to my up UXP connect command, which is essentially just going to create a secret in the Upbound system namespace that has that token in it. And the Upbound bootstrapper here is watching for that secret to exist. And when it does exist, it's going to create an agent that then allows me to view into the cluster from Upbound Cloud. You can provision this to be view only or be able to create things from the UI. We'll go ahead and do that. If we look at our pods now, we should see that our Upbound agent is getting created. We can also see that if we want to list our control planes in the Dan org, we now have our welcome Viktor hosted control plane and our Friday stream self-hosted control plane. And if we jump over to the UI, You also see that we have our Friday stream one here, and it came up really quickly, right? Because we didn't have to go and provision a whole cluster. We already had one running. And if we look into it, we once again have a control plane. Go ahead.
Here's the question. The communication from the agent goes agent to Upbound or vice versa as well?
It goes agent to Upbound. It actually uses NATs, if folks are familiar with that, another cloud native technology, to be able to perform that communication. And so everything is done over NATs. We actually have, I believe, some documentation on that in the Universal Crossplane repo. If folks want to check out kind of the technical details of that. Something else I'd add, which probably should have brought this up earlier, Universal Crossplane, the UpCLI, our SDK, all the components get installed into your cluster in the self-hosted situation are all open source. So you can go to the Upbound org and look at those. You could propose a feature. You could, contribute yourself if you'd like. They are, Upbound's distribution of Crossplane, but they are also open source. So that's a nice thing. All right, so we showed that you can, via the registry, install your packages and get your stuff in there. But like I said, we do everything through GitOps in our organization, and we want to even configure our control plane using GitOps itself. So since I've pushed this package, I am going to now go up to and I'll minimize some of this so it looks a little cleaner. I'm going to go up to my app of apps here. And I need to enable a control plane app. So this is basically going to provision the things in the cluster that configure my control plane and build those abstractions I was talking about. So I'm going to uncomment this. And then in my control plane directory that we're talking about here, I have my configuration. So I'm going to show both consuming that one we just pushed here. And let's make that v0.0.0.2. And this is going to install the configuration into the cluster. And then I'm also going to use this platform ref GCP one, which we looked at, which is just an Upbound kind of getting started package. And I'm going to install that as well. And what we're going to see is both of these are going to be installed into our self-hosted cluster. And they actually have common dependencies. So if we looked at platform ref GCP's source, it depends on provider GCP and provider Helm. Our GCP package, which has kind of the abstraction we want to add, is just depending on provider GCP. And we can see that once again by looking at our crossplane.yaml here and saying that we depend on provider GCP. What that means is that you can kind of take things off the shelf and also bring your own pieces into your cluster to really build that API with the least amount of friction, right? So if someone builds something that's really cool, just like, an open source library that you may use in your software, we want you to be able to use these platform building blocks to be able to construct your platform. If I wanted to, actually, if I said every time I use my GCP, I want platform ref GCP there as well, I could go ahead and in my crossplane.yaml declare a dependency on that, and then we would only have a single install. But like I said, I'm going to add this to my app of apps here. I'm going to specify I want both of these. Then I'm also going to create my GCP config, which points to a secret in my cluster that says provider GCP. This is how you connect to the external API to provision resources, which we won't be doing right now, but we will want to in the future. And so I'm going to go ahead and with our GitOps practices here, let's see. I am going to add my, let's see, apps local templates. So I'll add my control plane. So I uncommented that. And then I also wanted to make sure that I updated that control plane configurations and the other stuff we don't have to worry about right now. Let's see, install configurations. All right, and I am going to push that to my repository. And once again, we have this app of apps set up in Argo. So if we go back and we run a sync here, we should see that it is actually going to go ahead and create our new application here, which is our control plane application. and you're going to see the different resource that we created. So 2 configurations and a provider config. This provider config is going to likely fail at first because it'll take a moment for provider GCP to get installed. But if we went ahead and looked, and I believe I need to sync this just to speed it up a little bit. Sync failed. I might have a...
Probably dependencies that one depends on the other or something like that.
They should be... I think you're right. Here, let's go ahead and comment this out. I think it doesn't like that I'm trying to create this before the CRD is installed. I thought it would just retry, but I guess not.
No, it would. Just give it time. You're impatient.
Well, I am impatient. You're right. Will it actually try again? Or does it abort applying everything? Which we could actually see. Go ahead.
I think that the default in Argo CD default sync frequency is 3 minutes. But if you keep pressing that synchronize, it should probably get to it eventually.
Gotcha. Well, let's try it one more time and see.
Or maybe not.
Yeah,
no.
I don't know. We'll speed it up by just going ahead and commenting that out. Let's see. And I will push this as well.
This is cool. It's cool that you failed. It proves that you're a human and not a script.
Well, I fail quite frequently, so I don't know if folks needed the reminder or not. But here we'll see that our configurations are now successfully installed, so that's great. And if we actually looked into our control plane that's already up to date, you can see that our My GCP, which this is still being installed, is this one. But provider GCP is here, and we have all of our different GCP resources, as well as our Helm resource types. And once these are complete and finished installing, we'll actually see that our abstract Postgres type here is going to pop up as well. So what we've done, we haven't provisioned any infrastructure. What we've actually done is just allowed for developers to provision Postgres databases without having to understand that it's going to, become a Cloud SQL instance. So if we look at that, you can see that we don't have any Cloud SQL instances created at this time. So what I'm going to do is now I'm going to uncomment our provider config because we can create it with provider GCP installed. And the other thing I'm going to do is, let's go up to our app team 1. I am going to deploy our stream counter application, which is just a deployment that points to a container image that I pushed, a database request here that specifies a connection secret we want to write to. And you'll see that we'll consume that from the deployment. And then a service. We're going to expose this externally so that anyone watching at home can go ahead and hit this endpoint as well. And you'll see that we're setting this to app team 1 and stream counter DB for the connection secret. So I need to add all of this that's in the stream counter chart here. And then I also need to go into app team 1 and enable an application that targets that stream counter chart. So I'll enable that. Let me make sure my namespace is, all right, good. I've already got my app team namespace here. So I am going to, let's look at our status. I need to add everything in app team 1. I need to add my templates under apps. And I need to go ahead and also add everything in control plane so I get that provider config to be able to talk to GCP. So importantly, I haven't built this application super resilient. So that secret isn't going to exist for a little bit because it's going to take some time for that database to come up. But once that database does come up, that application is going to be able to start and connect to it. So, we haven't fixed the issue of it taking time to provision a database on GCP, but we have made it possible to request that via the Kubernetes API. So let's go ahead and add those. Make sure everything looks good here. Deploy stream counter. And I will go ahead and push that up. All right. And if we go back to Argo CD again, if all is well, I should be able to sync this and see that our applications are updated. So we don't have, so there's our stream counter application. And if we go over to stream counter, as I mentioned before, our stream counter deployment is going to fail for the beginning because it's going to say, I need the secret. That secret's not present. That's because the database hasn't been created yet. But you can see here that we're actually rendering out what happens with composition right here in the UI. And the Postgres SQL instance is what we created at the namespace scope in the app team 1 namespace. That resulted in the creation of a composite Postgres instance, which then provisioned our Cloud SQL instance by matching to our composition, which, like I said, in this case is matching to Cloud SQL instance. It could be an RDS instance on AWS, could be creating something in our cluster. Maybe we're deploying CockroachDB via their Helm chart into the cluster and using that instead. And then we also see some other kind of Crossplane components present there as well. All right, so let's hop over to our GCP console and see what's actually happening here. And if we go and look at our SQL pane, we should see that it looks like we don't have a cluster created yet. So let's see what's going on. In our Upbound Cloud console, you can see that we now have an instance of our abstract Postgres type. And what we want to be able to see in the Upbound console is how our abstractions result in actual infrastructure that's going to cost us money as an organization on the cluster. And I'm guessing what happened is the provider config that we added there hasn't been created yet, but we can go ahead and drill down and see. So our abstract type is unavailable. So let's look at the resources that are composed in our abstract type. It's our Cloud SQL instance. And since we have one resource and it's unavailable, then obviously our abstract type is going to be unavailable as well. And let's see. So, yep, my assumption was correct. It was unable to provide to find our provider config default, which we did add there. So I'm guessing if we go in and look at our control plane, and this is actually a pretty cool view because you can see how all of our dependencies get resolved. But we want to go ahead and sync this to make sure that our provider config, there it is, gets created. So now we have our default provider config, which is basically saying provider GCP, this is how you connect to the GCP API. And shortly, we will see some additional events here when Crossplane comes around and syncs this again. And this database is going to start to get provisioned. So that should come around pretty soon. You can also always, since we have the Kubernetes API here, you can use any other Kubernetes tooling that you like. So we like to say, some folks want to use Argo. Some folks are going to use GitOps, with Argo to do everything. Some folks may want to use something like Backstage. Some folks may want to look in the GCP console. We don't want to dictate, how you provision your infrastructure or how you monitor it. We can give you the best view from Upbound Cloud about how all your infrastructure is related, but how that actually gets provisioned is definitely up to you. And we're big proponents of using GitOps. But you can also just look into your cluster here. So I'll do a git GCP, which is just kind of a shorthand command that apparently is not going to work here. So let's try git Cloud SQL instances. And it looks like that our Cloud SQL instance is being created now. So if we go and look in here, and we can see that we do have a normal event here, and we successfully requested creation. This one is kind of a spurious error that's just from the Kubernetes API. But if we go over to the GCP console now, and I'll go ahead and refresh this, then we should see that our database is coming up now. Victor, you always make me feel good about a demo.
Hey, only a few minutes before the end of the session, so you did it.
Right. Well, we're not quite there because our application is still waiting, right? So if we go over and we want our stream counter to become available here, but if we look at, that's not the one I want. our pod here, we're going to see a bunch of events that say stream counter DB secret not found. It takes until the database comes up for that stream counter to be available, or for that secret to be available, right? Because we have to wait for GCP to give us that information. Once that secret is available in the namespace, so if we want to actually look at the app team 1 namespace, you'll see that we have our Hello World app as well as our stream counter one. And if we wanted to get secrets here, we can see that we don't have our database connection. But once our claim, which is the Postgres type that we created, gets created and is ready, we are going to have this connection secret available. So it doesn't take too long for Cloud SQL instances to come up. So if we start our wrap up now, I'm hoping that we can actually be able to access this by the time the outro is over.
Yep, hope dies last.
Right, exactly.
But yeah, we need to go for the wrap up. We have 3 more minutes. But this was, at least for me, it was extremely useful because I was exposed to Crossplane before, but not to the cloud and not to the details. This is really cool.
Absolutely. Well, I hope it was useful to you. And, I like I said, I'm sure that you'll make a lot more content that's more useful to folks. But that was a perfect wrap up because this is now available, and our pod should also be coming available here shortly. It is running. So I just want to briefly show that if we get our service, don't remember what it was called, but it was in App Team 1, and we go to our external IP here. This is a load balancer service. We should see welcome to the stream. And we do.
Yeah.
All right. So just like that, let's recap what we did. We defined abstract types, or a kind of layer 2 cloud provider that we wanted folks to be able to interact with within our organization. We installed those abstractions into our cluster and had Crossplane kind of manage them for us, which also brought along our providers that we required. And we also deployed an application that consumed one of those abstractions, and we're able to view that relationship in the Upbound Cloud console. So I'd say that's a pretty full day. Once again, pretty simple example, but I hope this gets the wheels turning for different users to be able to create things. If you create packages that are useful, please publish them for other folks to consume, and we can really see what kind of awesome abstractions that folks build.
Brilliant. That's a wrap. We're out of time. Now I need to repeat everything you did later tonight.
Well, it's all because we practice GitOps. It's all in the repo. So I'll update the information there for other folks that want to try it out. But thank you for joining me today, Viktor. And I'm excited to see what you do over the next few months.
Does it mean that you're planning to get rid of me after a few months? Is that what you're saying? I
mean, I guess it depends on how you do, right? No, we'll keep you around, I'm sure.
Cheers, everyone.
Awesome. Thanks for joining, folks. See y'all.